Measuring basicity and nucleophilicity. Let's see how do we actually measure basicity and nucleophilicity. So to begin with, let's see how do these reactions of nucleophiles at hydrogen differ from reactions of nucleophiles at carbon. So let's look at this reaction once again. Ammonia two lone pairs of electrons on oxygen. You know this pair of electron of nitrogen is donated to the proton and it forms NH4 plus plus OH minus. How many pairs of electrons on oxygen now? Exactly 6 pairs of electrons, 3 pairs of electrons. So it carries a negative charge. Now what you must have noticed here is this reaction is reversible. So there is going to be an equilibrium. Since it is reversible, there is going to be an equilibrium. So if you can measure pKa, we are measuring the basicity. So let's see how the pK values tell us about basicity of a species. The pK value of the species H2O, pK value is 15. And that of NH4 plus pKa value is 10. Now this is an acid because it is donating a proton. This is an acid again because it is donating a proton. As you are aware, NH3, when it is becoming NH4 plus, the base NH3 is becoming its conjugate acid. Similarly, the acid H2O is becoming its conjugate base OH minus. So if you see the values, the pK values, higher the pK value, weaker the acid. So what it means is H2O with pK value 15 is a weaker acid. This is a weaker acid. Compared to NH4 plus. So NH4 plus is a stronger acid. By the same argument, you can say NH3 is a weaker base stronger acids make weaker conjugate base, or weaker bases make stronger conjugate acids. So we are coming to a conclusion that NH3 is a weaker base based on the pK values. So obviously OH minus is a stronger base. Weaker acid makes a stronger conjugate base. So this pK table helps us to measure the basicity. So we have come to the conclusion that OH minus is a stronger base than NH3. But in the case of nucleophilicity, is this possible? Let's look at the reaction once again. OH minus carries a negative charge. The same reaction which we had discussed while discussing about nucleophiles and bases. You know, this carbon carries 2 hydrogen atoms. The electron pair of oxygen attacks positively charged carbon, and a new bond is formed between C and OH minus. Now this is the most important part of this reaction. You can see it is an irreversible reaction. So this is CH3 C, a new bond is formed between C and OH minus. Plus Br minus. So you can see, since it is irreversible, this is irreversible. It's not going to come into equilibrium, which means we cannot measure the equilibrium constant for the reaction. As you remember, basicity we measured by measuring the equilibrium constant. So how do you measure the nucleophilicity then? So to measure the nucleophilicity, you have to measure the reaction rates. So rate of the reaction you measure to understand the strength of nucleophilicity. But you need to remember, they do not always reflect the overall stability, because there are some more variables at play, like steric hindrance, and the kind of solvent we use. So the effect of these two variables we will discuss in the next video, next class. So what we have learned is, we measure basicity by measuring the pK values, or by measuring the equilibrium constants, whereas nucleophilicity is measured by measuring the reaction rate. So there is a way in which, there is a difference in which we measure basicity and nucleophilicity. The variables which are at play, like steric hindrance and solvent, effect of solvent, we will discuss in the next class.